Let's integrate 4x squared minus 3x minus 4 all over x cubed plus x squared minus 2x. Okay, so I notice it's one polynomial over another. That to me suggests partial fractions. So we're going to have to rewrite. In fact, we'll drop the integral sign. We'll bring that back later. We're going to have to rewrite this. Now, the first thing to rewrite this and do a partial fractions decomposition, you need to know the factors in the denominator. So I can take out a factor of x here. I'll be left with x squared plus x minus 2. That's quadratic. We can factor it, let's see, an x plus 2 and an x minus 1. So now we can set up our partial fractions decomposition. Okay, so we can rewrite this rational function as a sum of these simpler rational functions, and these are easier to integrate. So what can we do? Well, if you multiply both sides, check this out for yourself. Multiply both sides by this denominator, x cubed plus x squared minus 2x. You'll find yourself looking at a, and then we get the x minus 1, x plus 2. B, x times x plus 2. And c, x times x minus 1. And we're going to plug in different values for x, make the left-hand side equal the right-hand side, and solve for these constants. Now, you can use whatever values of x you want, but there are some that are faster than others. For example, if I pick 0, I notice that both b and c have x beside them. So if we let x be 0, get a negative 4 on this side, you'll get a times negative 1 times 2, b times 0 times 2, c times 0 times negative 1. Well, anything times 0 is 0, so we can ignore those. Negative 4 is negative 2a. So whatever the other constants are, a must be 2. Great. Okay, now what if we were to let x be 1? What effect's that going to have? Well, this x minus 1 will be 0, and this x minus 1 will be 0, and we will just have b alone by itself. So if x is 1, we'll get 4 minus 3 minus 4. That's going to be negative 3 on the left-hand side. A times 0, c times 0, and then b times 1 plus 2, so b times 1 times 3. So negative 3 is 3b, b is negative 1. So we know a, we know b, let's figure out what c is. How can we figure out what c is? Well, if we plug in negative 2, that should make the coefficients of a and b 0. Now I have to do a little bit of work. Negative 2 squared is 4. 4 times 4 is 16. Minus 3 times negative 2 is negative 6. And then minus a 4. Okay, a times 0, b times 0. And now we get c. So x negative 2 and then negative 3 for negative 2 minus 1. Okay, so 16 plus 6 is 22, minus 4 is 18. So 18 is 6c. C must be 3. So there we go. We are all set with our partial fractions decomposition, which will allow us to integrate. So that's a. What was a? A is 2 over x. Okay, b is negative 1 over x minus 1 there. And then the c we just worked out was 3. 3 over x plus 2. There we go. So now if we integrate both sides, Using the sum and the difference rules, we can make this go quickly. Okay. And we can pull out the 2 and the 3 as well, since they're constants. So 3 here, 2 here. And, well, we know how to anti-differentiate 1 over x. So you get ln absolute value of x minus ln absolute value of x minus 1. And then 3 ln absolute value of x plus 2 plus c. So there we go, fantastic answer. That's not the only way to express it, because of course we can combine things using our logarithm rules. Okay. We could say that this is ln absolute value of x squared. And bring the 3 in and say ln absolute value of x plus 2 cubed. And then a sum of lns turns into a multiplication, and a subtraction turns into a division. So another perfectly acceptable way to write this, x squared x plus 2 cubed all over x minus 1. Okay, so ln of that plus c. So that's perfectly fine. Me personally, I prefer the long way around, but it's good to remember that because of all these natural logarithms, log rules still apply, and so we can combine them if space is an issue and want to express things a little more shorter in terms of line space.